Alright, let's take a look at this graph and see if we can figure out how to write the piecewise smooth parametricization of C. Okay, so here's our graph, and we want to see if we can write the piecewise parametricization of the path C. So we're going to have R of t equals alright, and let's see, looks like this thing goes from here to here and then goes from here to here. So that means that we're going to have two equations. We're going to have an equation for this from here to here, and we're going to have an equation for this from here to here. There's more than one way to do these too. So whatever I write up here, you could probably think of other equations that would work out. So if you think of it a different way and you still get equations that work out, then that would mean your answer would be right, even though it's different than mine. So this is 0, 0, and this is 1, 1. So on this interval from 0, 0 to 1, 1, it looks like that's the interval 0, t equals 0 to 1 is what I'm going to choose. You can tell it says this equation is y equals x. So we have an equation of the line, which makes this a lot easier, really. So how could we go from 0 to 1 and 0 to 1? So you want to go from 0 to 1 on the x and 0 to 1 on the y. One way to do that would be t times I plus t times j, right? When t equals 1, you'd have 1, 1. And there's probably other equations you could choose, but that's the way that I see that. Now this next part, this is a little tricky. We want to go from 1, 1 back to 0, 0. And I'm going to say this is the interval t equals 1 to 2. And we have this equation to keep in mind too. Y equals the square root of x. Because we would have an infinite number of points here. So what do you think we could do for the x term? Remember, whatever equation we use needs to work for any value of x through here. Y equals the square root of x. Yeah, this is a little tricky here. So we have y equals the square root of x. Or, I mean, that's the same as x equals y squared. Keep that in mind. But just the guess that would be just the positive part. But we're going this way too. We're going back to 0, 0.
So on each one of each piecewise function, do they go up to the next? If you had to have the next one, would it be 2 to 3?
If we had another curve that went like this from there, and we could tell that it probably wouldn't be like that, but yeah, then it would be, you know, t equals 3 out here at some other point. So each curve, we have to increase t. Now, we could increase it by more than just 2 if we wanted to, or more than just 1 if we wanted to. But this is probably the best bet. Just kind of try to keep it as safe as possible here, as simple as possible. Alright, so whatever equation we use, and we know this is the curve y equals the square root of x. Whatever equation we use, when we plug in a 2, we want to get 0, 0. But when we plug in a 1, we want to get 1, 1. And keep in mind that this is the curve y equals the square root of x squared. So at any point here, I could figure out some x and y point on this curve will need to work with our formula. Oh, yeah, this is very tricky. So what if I let the x value, let's see, so we want a 1 here and we want a 0 here. When we let t equal 1, we want a 1 here. When we let t equals 0, we want a 0 here. I mean t equal 2, we want a 0 here. So that would be, what if we did like 2 minus t? I'm just throwing something out there, and let's see if this works. So when I plug in t equals 1, I want to get a 1 on the x. I do. When I plug in t equals 0, I mean t equals 2, I want to get a 0 on the x. So that would work. Alright, what about the y? Could we do the same thing? We have y equals the square root of x, though. Right? If y is equal to the square root of x, then could I do this plus the square root of 2 minus t times j? Y is the square root of x. If this is my x component, could I do that, and would that work? So if I let t equal 1, I would have t equals 1. I need to get a 1 out from my y. That would happen here. No. And then if I plug in a 2 here, I get 0 on the j. So it's important because of the way this curve is. If it was a straight line back on top of this line, then it wouldn't be that important, but it is because of the way that we have this is defined. Alright. Let's do another one of those. These are pretty tough. I mean, this isn't just something you can take and run with, really. You got to kind of analyze the graph and think about it for a while.
So the reason you put that square root over it is because y equals the square root of x?
Yeah, since y was the square root of x, that's why I put that square root over it. And it still worked out because y was equal to the square root of x. Alright, so I'm just thinking about these different equations we have here. Like, I know this equation right here is x equals 0. This one up and down here. So that's, this line here is x equals 0. This line here is y equals 4. and then we have y equals x squared there. How many equations do we need to have?
3.
We need to have 3. Because we have 3 different curves. So right here is where t equals 0. Right here is where t equals 1. Right here is where t equals 2. And then again right here, that's going to be where t equals 3. And the way I know that's because of the way the arrows are going. Okay. And remember, you can come up with, we don't have to use 0 to 1, 0 to 2, 0 to 3, just as long as it works with our equations. We can try to set up one that's 0 to 1, 0 to 2, and 0 to 3. If you can't get it to work out, then maybe choose other numbers. And the reason I say that, the reason I even mention that, is because these are even numbers, and you know, when I plug in a 2, I want to get out a 4 for the y, right? When I plug in if I plugged in a 4 for the y, I'd want to get out a 2. So we know we're going to have 3 here. I'm going to have t greater than or equal, less than or equal, t greater than or equal, less than or equal, t greater than or equal, less than or equal. All right. So we want to go, and this, remember, whatever equation we use here, y is equal to x squared. So whatever I plug in, if I plug something in here for y, and I plug something in here for x, and I squared it, I would have to get the same thing. Alright? So we want to try 0 to 1 to see if we can get that to work. Would 2t work? 2ti plus 2tj, or is it 2t squared? Okay, so let's see if this would work. So if I plugged in a 0, of course I get 0, 0. If I plugged in a 1, I would get the point 2, 2. I'm going to try 4t.
Just bring the 4t and not square. Because you plug in a 0, that's 0, and you plug in a 1, that's 4.
You would put it all in parentheses at 4, the 2t parentheses, then raise it to the square.
Well, let me get back to what he was saying. We can't make it just 4t because y has to be equal to x squared. So whatever we put here has to be this squared. And so we're talking about like this. So that would be 4t squared. 4t squared. So when I plug in a 0, I have 0, 0. When I plug in a 1, I have 2, 4. So that would work. That would work with 0, 1. There's other things you could come up with, like for example, and I'm going to erase this, but I just want to show you that it would work. If I was to let t be between 0 and 2, and just say like I'm going up by 2 every time, like t equals 0, t equals 2, t equals 4, t equals 6. If I was to do that, then up here, this would also work. But that's kind of like, because, I mean, this would work for that first part. But, again, you can have multiple answers here. So, that works. Okay? And so now we want to go from 2, 4 to, what is this point? 0, 4.
Once you've done one, from 0 to 1, do you have to go up by 1 every time? Or can you
You probably want to stay consistent, but you don't have to. So you can change the t's to fit your equations, or the boundaries. No, that they would not be able to overlap. They need to, well, when I say overlap, they always will overlap. Like, say this has to start with 1 now. We can't skip anything. So that does kind of overlap. So whatever equation we come up with here is also going to have to work here. So it's going to have to work here, and it's going to have to work there. To change that from x equals 2 to x equals 0, so let's say we go from 1 to 2. We're going to have, how can we change the I by 2? Let's see. 2t I don't know, I'm just thinking. So when it's 1, I want to get out, when t equals 1, I want to get out x equals 2. But when t equals 2, I want to get out a 0. What if I did this? All right, so when t equals 1, I would get out a 2. And when t equals 2, I'd get out a 0. And I'm completely making these up because I don't know of another way to get that, but I'm sure there's 1,000. There's several ways you could get it. That's the I component. Now, what happens to the j component? It's going to stay 4. So, what if I just do 4j? Regardless what you plug in for t, it doesn't affect that one. It stays the same.
Is that kind of like understood to put that, what if you did like 2T or anything?
If you did 2t, would it still work? When t equals 1, you'd get out a 2. And you want to get out of what? You want to get out of 4 for the y. Alright. Now the last one. Here to here. So we're going to go from, t equals 2 to 3. We got 0, 4 to 0, 0. Well, that means that we're not going to have an x component. It's going to be 0i, because if you want 0 here and 0 here, you can just say 0i. The j is what we're going to have to adjust. We want to go from y equals 4 to y equals 0 when t equals 2 and t equals 3. What would 4 minus, no, I guess 4 wouldn't work. What about 3 minus, I don't know if that's not going to work. T equals 2, you get out of 1, we want to get out of 4. Alright, so if we want to get out of 4, when t equals 2, that would be a 6. Alright, so if t equals 2, we get out of 4. T equals 3, we get out of, we want to get out of 0. So basically this times t needs to be equal to, let's see, what is 3, 9, this is definitely tricky. We know it's just the j. What about I'm just throwing some things in here to kind of
What if you change your T from 2 to 6? So, that same 6 minus T that you just had.
okay. So would that work? Let's see, 2 would make that a 4j, and 6 would make that a 0. Awesome. That's a good idea.
So there's not have to be any order. You can just.
Yeah, you can adjust the t's ever how you need
So
to.
they don't have to be in.
No, they don't have to be, I guess, partitioned evenly.
Yeah, like going up one each time.
Yeah. A lot of times when you're coming up with your equations, it will help you to do so, but you know, here we adjusted and figured out the equation, so everything worked out good.
So that first number has to equal the one above it.
Yeah. This one has to be equal to that one. Is that what you're asking?
Yes.
Yeah. Because it needs to be continuous. I'm going to show you an alternate way to do this, just to have another example on the same problem. Like I said, there's many ways to do it. So here's another way that would work out. Ti plus t squared j, t from 0 to 2, 4 minus t times I plus 4j, t from 2 to 4, that's a minus t, kind of hard to see there, let me rewrite that, 4 minus t, and then 8 minus t times j, t from 4 to 8. Okay. That would work out for this figure as well. There's more than one way to do these. If I give you one like this on the test, I'll try to make sure that it's something that's not too hard to figure out, or something very similar to something we've worked in class, because these can be rather complicated. I understand. They're hard for me to do up here on the fly, so I don't expect you to be able to do it on the fly either. Alright, let's look at a line integral. So here's an example of a line integral. The integral over c of 3 times x minus y ds, where c is r of t equals t I plus 2 minus t times j, t is greater than or equal to 0, less than or equal to 2. Yes, all this is given. So what we're doing, we're going to evaluate this line integral along this path. Alright, so if r of t, let's see, r of t is equal to ti plus 2 minus tj, this was given in the problem, I'm just rewriting it. Then what is r prime of t? So the derivative of the x component with respect to t is 1. That's 1i. Plus the derivative of the y component with respect to t is going to be what? Negative 1. So that's minus j. So really I have the derivative is I minus j. Okay. So you can see this right here is x of t. This right here is y of t. So that means that we have x prime of t, it's 1, and we have y prime of t, it's negative 1. Okay. Now our interval here was from 0 to 2. So my integral is going to be from 0 to 2. Because t is between 0 and 2. So this is going to be the integral from 0 to 2 of 3 times, what is our function in terms of x of t, y of t? It's this over here. So our function is going to be t minus, and then this is that right there, this right here. So it's going to be minus 2 minus t.
That wouldn't be t plus.
It's going to end up being, yeah, it's x minus y. It's going to end up being plus. But so this right here from our formula is our f of x of t, y of t. And then we have that times the square root of x prime of t squared, so 1 squared, plus y prime of t squared, negative 1 squared, dt. Alright, so that's going to be, this is a product too. So the 3 can be brought out front. This right here is going to be the square root of 2. That can be brought out front. So this is going to be 3 square roots of 2 times the integral from 0 to 2 of, now what do you get right here? You get t minus 2 plus t. So that's still 0 to 2. That's going to be 2t minus 2 dt. So this is 3 square roots of 2. That's going to be times t squared minus 2t, evaluated from 0 to 2. So it's 3 square roots of 2 times 4 minus 4 minus 0 minus 0. So it's going to be 3 square roots of 2 times 0, or 0. So all of that to get 0. Could be worse. Alright, let's look at another one. One more example. Let's do the integral of 2xyz ds along the curve r of t equals 12ti plus 5tj plus 84tk, where t is between 0 and 1. Alright, so here's r of t. I'm not going to write it down again. R prime of t. Remember, we have to differentiate each one of these parts with respect to t. So that's going to be I. How many I? 12i plus 5j plus 84k. Now this integral is going to be from 0 to 1, and now we need to change this function into a form of t. We need the x of t, the y of t, the g of, or the z of t. So this is going to be 2 times 12t times 5t times 84t times the square root of 12 squared plus 5 squared plus 84 squared dt. So that's going to be the integral of big number here. Let's see. We got 2 times 12 times 5 times 84. So that's a 10,080 t cubed. Let's see what the radicals equal to. Probably gave us something that's going to come out pretty. So 144 plus 25 plus 84 squared is 7,225, and the square root of that is 85. Alright, so this is going to be 856,800. That's what you get when you bring that out front. And then this is going to be t to the 4th over 4. Evaluate from 0 to 1. Well, I'm just going to put it here. 0 to 1. So it's going to be 1 minus 0, or 1/4 minus 0. And when you divide that by 4, you're going to get 214,200.